Correlation coefficient. So our correlation coefficient is a measure of how close the points are to our line. So if every one of these data points hit our line of best fit, that would end up being an R value of -1. Okay, so that would be every point, so it would be a linear relationship, and it would be in a negative direction. Anything negative, so with that slope going down to the right, is going to be somewhere in this range here. Anything with a positive slope is going to be somewhere in this range here. So I'm going to add a little bit to this little scale here. Okay, so for this kind of scale here, I added this in my filled in notes if you want to see it a little bit better here. So as we get closer to -1, that would mean the points are getting closer and closer to the line, and it is a negative slope to the line. It has a negative slope to the line. As we get closer to +1, we are getting closer and closer to a linear relationship that is going up to the right. Okay? As we get closer to 0 from either direction, there is a less and less visible representation, or less and less of a relationship available here. So if I were to draw something, okay, if that's our scatter plot, we could say that this would have a correlation coefficient here, R would equal 0. There's no real relationship. You can't really say that this is going up to the right or down to the right. You could roughly encompass our points with a circle. That's another thing that we kind of taught in grade 9. So if we compare that one to this one here, okay, so I can roughly fill all of my points in that pretty tight oval here. This would have an R value, I would say -0.9, something like that. So we would be in that strong, so this would be -0.66, -0.33. Okay, so we'd be somewhere kind of in this range here of it having a strong and negative correlation and an R value roughly -0.9. Now, just kind of like our line of best fit, we're going to do we can kind of guess a value, like I'm guessing here, but we would really need to use our calculators, our online calculators, to get an accurate value here. Okay, so this might not be exactly 0. It might, if you enter all the data points, it might say 0.1211, give you some messy decimal number. So we would have to use online software to get accurate values for these. Okay, so we can only kind of estimate based off of how reasonably do these points follow our line of best fit. Okay, a residual. So this is something in 8.3. So most of this stuff here that we've touched on so far is from 8.1. 8.2 is a list of definitions of some different types of relationships between your variables. I'm going to let you guys read through that. You're going to need to kind of connect your research to those relationships, and that'll all be in the rubric. It'll all be in our list of stuff that I'm going to expect from you. We'll get closer to that stuff later on. Right now, all we're going to worry about is just learning this stuff for now, and we're going to apply it later on. Okay, so 8.2, yeah, read those different types of relationships and kind of have an understanding of kind of the differences between the set there. Okay, residuals. So a residual is the vertical distance between the point and the line of best fit. A residual plot is essentially taking your line of best fit and turning it into a horizontal line. So if I drew a residual plot here, this is kind of our line of best fit. My first point here is a little bit below, so let's say it would be here. Our next point a little bit more below. Our next point was here. Our next point was really close. Okay. And all I'm doing here is sketching all of these distances here. Okay, so each distance from that point to the line of best fit is called a residual. A residual plot is taking that line of best fit, turning it into a horizontal line, and showing the distances from those points to the line. Okay, so as these distances get smaller, you would get closer to a positive one or a negative one. Okay, so the more spread out these points are, the closer we would get to a zero correlation or an R value of 0. If you see R squared in some of those online calculators, all that's doing is just giving you a positive, always a positive answer. So they're kind of ignoring whether it's positive or negative. They're squaring it and only kind of worrying about this portion of our scale here. Okay? So definitely read through the examples that I posted. And then that leaves us with these last two. Okay, so an outlier, you guys have seen this one before. That would be if like a point shows up way up here. It's really far off the rest of the data. We actually have a calculation to see if something is an outlier that we touched on in the previous chapter. And a hidden variable. Okay, so I'm running out of room here, so I'll do this here. If we saw something okay, so if we had a graph that looked like this, so for a chunk of it, it looks like our line of best fit should be something like that. But then for some reason it dips down and starts increasing again. Now, there's something in this that you are being told about, or maybe you are being told about it, but there's something that's factoring into why the graph turned out this way. Okay, so for example, if we're looking at, I'm going to change these points up. Okay, so if we were looking at a new restaurant and the sales at that new restaurant, and you can see that as time is increasing, the sales are going up, they're doing a fantastic job, everyone likes the food, and then for some reason, now our points are way down here. So in this case, we could take real life and our COVID experience here. A business like that is going to suffer. So there's nothing they could have really done to prepare for COVID-19. So this might be their sales now. Maybe they just have a bit of takeout. Okay? So our relationship, what I would do and what you should do for your project, if you encounter something like this, then you know what? Look at two different portions of the graph separately. So maybe say from 2010 to 2020, oops. We were here from 2020 on, we're seeing something like this. I would look at those two different periods of time separately and then kind of discuss the hidden variable and how that factored into that outside influence that changed the results on the graph. Okay, so I think I touched on just about everything. You're going to have to read through 8.2 and kind of go through those definitions. But 8.1, 8.3 is this kind of stuff here. So I wanted to make a video kind of outline some of that stuff. All right, hope you guys are doing well. Looks like we got at least another month of this, so get used to seeing my face on a YouTube screen. I hope this stuff is helping. Give me some feedback. I'm kind of blindly throwing darts in the wind here, hoping this stuff is going to be helpful. Let me know if it is, and I hope you guys do well and are doing all right in your classes there. Talk to you later.